In this video, we will describe the empirical rule and how this rule can be used to solve some story problems. The empirical rule is also known as 68, 95, 99.7 rule. This rule only works for normal distributions. Simply put, this rule says that the probability within one standard deviation away from the mean, that is mean plus minus one standard deviation, is about 68%, and about 95% within two standard deviations, and 99.7% within three standard deviations. Because 99.7% is very close to 100%, this implies that almost all normally distributed observations should fall within three standard deviations away from the mean. We can also re-express these statements in terms of the z-scores. Probability of a z-score being between minus 1 and 1 is 68%, and between minus 2 and 2 is 95%, and between minus 3 and 3 is 99.7%. We calculated these probability statements using the z-table, and then approximated the exact probabilities to three numbers, 68%, 95%, and 99.7%. It is clear that the empirical rule is an approximation to the z-table. On this bell curve, besides labeling all those three numbers appear in the empirical rule, I've also provided other probabilities that are calculated using the empirical rule. For example, the probability between two standard deviation and three standard deviation above the mean is 2.35%, and the probability of having a z-score of less than -3 is 0.15%. Example 1. A wire of 1,050 microns is 50 microns above the mean. That's 50 standard deviations above the mean. From the empirical rule, we know that it is very unlikely to have an observation that is 3 standard deviations above the mean. So it's impossible to have a micron 1,050 microns when the mean is 1,000 and the standard deviation is 1. In example 2, we are looking at the mileage of tires, which is assumed to follow a normal distribution, with a mean 30,000 miles and a standard deviation of 5,000 miles. 15,000 miles is 3 standard deviations under the mean, so it has a z-score of -3. The percentage of tires that will be returned under the warranty is the same as the probability of having a z-score that is less than -3. Using the empirical rule, that is 0.15%. It's important to know that if you were to use the z-table to find this probability, the answer will be 0.13%, which is fairly close to 0.15% from the empirical rule. Since this question specifically asks to solve this problem using the empirical rule, we would have to use the empirical rule to do that. Part B asks that we can accept up to 2.5% of the tires for return. What is the warranty level? We go back to the diagram for this empirical rule. If we add up the two probabilities on the very left, that is 0.15% and 2.35%, their sum is just 2.5%. We should set the warranty level to be 2 standard deviations below the mean. The new warranty level should be 30,000 miles minus 2 times 5,000, that is 20,000 miles. Again, this problem should not be solved using the z-table. Although the empirical rule is quite powerful, it is also important to see the limitations with this rule. There are many problems that cannot be solved directly using this rule. That's why we would have to use the z-table or other computer softwares to solve most of the problems involving normal distributions.